in section 6 we're looking at polynomials. In this second part we'll look at two theorems that are going to help us with these polynomials. The first one is the remainder theorem, which tells us when we divide the polynomial p by x minus a, the remainder will be the value given by polynomial p evaluated at a. So in example 1 we could divide the polynomial p through by x plus 3, but an easier way is to use the remainder theorem. If we take the expression we're going to divide by, x plus 3, and set that equal to 0, we can solve this to get x minus 3. This is the value, x minus 3, this is the value we need to put into the polynomial p to find the remainder. So if we now evaluate the polynomial at minus 3, we get 8. This tells us the remainder when we divide p by x plus 3 would be 8. The second theorem is the factor theorem. This is a special case of the remainder theorem. This is where there is no remainder. This is telling us that if we evaluate a polynomial at a point A and we get the value 0 out, this tells us that x minus a is a factor of that polynomial. And this works the other way around as well. If we know that x minus a is a factor, then we know if we evaluate the polynomial at a, the answer should be 0. We can use this factor theorem to help factorise cubic expressions. So the first thing we need to do on this cubic is to find a number, so that when we evaluate the polynomial at that number, we get 0. So first we're going to try 0. If we put that into the polynomial and evaluate it, we get 6. So this tells us that x, or x plus 0, is not a factor. Okay, so let's try another number. Let's try minus 1. If we evaluate the polynomial at minus 1, we get 8. So again, this means that x plus 1 is not a factor. Well, let's try plus 1 this time. P of 1, this evaluates to 0. Good, because this means that x minus 1 is a factor. So now we've got one factor of the cubic. So we're going to now factorise the cubic into the factor x minus 1 and a quadratic. The cubic term, x cubed, must come from the x times the x squared term here. So that first term must be x squared. The number term, 6, must come from minus 1 times the number in the quadratic. So this number in the quadratic must be minus 6. Now to get the linear term, the x term, we can look at the x squared term in the cubic or the linear term. Let's look at the x squared term. The x squared term comes from minus 1 times x squared, so that's minus x squared. So the other x squared term, we need another minus 1x squared. So x times minus x gives us another minus x squared that we need. If we want to check this, we can check this works for the linear term as well. We have x times minus 6, that's minus 6x, and we have minus x times minus 1, which is plus x. So we have minus 6x plus x, which gives us the minus 5x which we want. Now that we've got a linear factor and a quadratic, we should be able to factorise this quadratic. We need to think of two numbers that multiply to minus 6 but add together to minus 1. So we get plus 2 and minus 3. So we've now factorised the cubic completely. Here is a typical exam question for you to try. Press pause, and once you have finished doing it, press play again to see the answers. Okay, part A. Part A says use the remainder theorem to find the remainder when p is divided by x minus 2. This means that you must use the remainder theorem. You will not get any marks if you find the remainder by doing a division. So to remember what number to use, what x to put into p, we set the thing we're going to divide by, in this case x minus 2 equal to 0, and solve this. So in this case x plus 2. We need to evaluate p at 2. So if we substitute the 2 into the expression, minus 12. The remainder will be minus 12. Part B, we need to show x plus 2 is a factor. So again we're going to set x plus 2 equal to 0. Solve this, so we now need to put minus 2 into the polynomial, and hopefully we get an answer of 0. So p minus 2 gives us 0 as we wanted. So because p of minus 2 is 0, x plus 2 is a factor of p. Part C. We're going to split the cubic up using the reverse table method. So we write x and 2 down the left. Our cubic expression is going to be inside the table, and our quadratic expression will be across the top. We add the x cubed x times x squared at the top gives us the x cubed. We can now fill in the term at the bottom. This term, the x squared and the x squared term from this part of the table, have to add up to minus 4x squared. So the second term must be minus 6x squared. Now again we can find the expression at the top to multiply by x to give us the minus 6x squared. This must be minus 6x. We can now find the term at the bottom of the table, and again we can now look for the two linear terms, minus 12x and the unknown expression here needs to add up to minus 7x, so this expression must be 5x. The part at the top must now be 5, and at the bottom we have 10. Notice how this 10 is what we actually need. This should be right, as x plus 2 is a factor. Now that we've split it up into a linear term and a quadratic, we should be able to factorise the quadratic. Two numbers that multiply to 5 but add up to minus 6. So that's minus 1 and minus 5. In part D, we need to sketch the cubic. So first we need to think about the factorised version. From the factorised version we can see that when y is 0, x is -2, 1, 5. So the graph crosses the x-axis at -2, 1 and 5. If we put x equals 0 in, we find that y is 10. So the graph crosses the y-axis at 10. We can now sketch the graph. So we've got the basic cubic shape that goes up at the top right and down at the bottom left. We know this is this way round because it's a positive in front of the cubic term. We now need to add the labels to the axes: -2, 1 and 5 for the x-axis and 10 for the y-axis. I'll leave you with the key points from this section.